prioritize your math a little bit more. All right, here we go. Oh boy, this is a big one. So what are we gonna do first?
Wait, are we in our notes packet?
Not equal to 0.
We're on practice test 1, picking up where we left off yesterday.
This is for, did this do B?
We are starting on C. I don't care. We're starting on C.
Yes, ma'am.
Yesterday I videoed this class up through B, so it's on video. If you weren't paying attention or whatever, that's fine. We have got to get going. Starting on C, this problem right here. So we need horizontal, vertical, and holes. All right, so what do? They're back there. Here we go. What do we do first? Factor everything. So on the top, I can take out a 3. And then I notice when I take a 3 out, I can factor into the difference of squares. Right? Where's yours from yesterday, Laz?
Huh?
Where's yours from yesterday?
I forgot my binder.
What about the bottom?
Factor.
How does that factor?
Well, 3 times
Minus 3 minus 1. Yep, that's exactly how that factors. And then what do we notice? This did not happen yesterday.
There's a hole.
Now we can cancel. And that means
We have a hole.
that there will be a hole in my graph. This one will have one because that's how we get them when things cancel, right? Now, because that factor canceled out, it means the x-coordinate of my hole is 3. And then to find my y-coordinate, I will plug in 3. So I will get 3 times 6 over 2. I'm putting in 3 for the x's. And that gives me 9. 18 divided by 2. So there's where the hole is. Now, let's look at this right here, part of the problem that was left over. Does it have a denominator? Yep. So it will have a vertical asymptote, and where will that vertical asymptote be? X equals 1. This is the vertical one, comes from the denominator. Vertical asymptotes come from the denominator. And then how about a horizontal? Where does that come from? That comes from, now you can go all the way back to here, that would be fine. You can also do it right here, it doesn't matter. Either place, the horizontal asymptote is going to be y equals 3. Alright, now we're going to do some sketching. Alright. So I'm going to try to squeeze a couple in here, so I'll come back and do A in a second. I'm going to do B because it's really easy. What shape is B?
V.
A V. But instead of being a normal V, it has been moved, not down 3, not up 3, to the right 3. It's been moved right 3. Now, you guys, I had the rules on the board one day. You need to go back and review them. When the number is inside the problem, see how it's inside the absolute value? That's left and right. If it had been this, that's different. That is down. And now I want you to label this point too. Always label that point. All right, C. C is a little bit harder. Sines and cosines are harder than V's. These are easy. the normal sign. The normal sign starts at the origin and goes up and down 1. Would everybody agree that is the normal sine curve? And it keeps going if you want. Now, what have I done to this curve?
Down.
Down 1. So that means instead of starting here, it's going to start here. But it's still going up and down 1. So don't make it bigger, it's still the same size. The hill's up 1 and down 1. So the red one is the answer to that question. All right, D. I'm gonna come back and do A in a second. D. What shape is D? Parabola. How do we know it's a parabola?
Square.
It's something squared. That's what parabolas are, something squared. Okay, we gotta know our BFFs. Okay, but what about this parabola? It is not at the origin, which is normally where it is. Where is this one? To the left 1 and down 2. So left 1 and down 2. So now I'm here, left 1, down 2, and there's my parabola. That is a perfect problem to look at the different rules. This one went left, that one went down. Because one is inside the parentheses and one is outside. All right, how about this one?
Double parabola, half cup.
So, and a couple of you on your BFF paper, you did my little parabola trick, but you left that. That is not the picture, right? If you wanted to set up that way, it's okay, but you gotta erase this piece and this piece. So that's the picture. But what's happened to this one?
Right one.
Which way?
Up
Up 1. Is that 1 inside of parentheses? No, that would look like this. That's not what this looks like. Okay? So I'm gonna draw that same picture, but I'm gonna draw it up 1. So it looks like that. And then the last one, what shape is this? That's a square root, so it's the one that goes up and out. But it's not starting at the origin, it is starting
Plus
Up to.
3 to the right and up 2. And then up and out. So there's the shape, but we've located it at 3, 2. All right, now I need to do the first one, because I skipped that one. Yep. What? Hurry up. Take the pass. Okay, so this one is harder than all these because this is gonna be in 2 pieces, right? 2 pieces. The squiggly line or the break in the picture is going to be at 2. Now I'm just gonna ignore that and I'm gonna graph my things. So I'm gonna graph y equals 2x plus 1. Y equals 2x plus 1 has a y-intercept at 1 and a slope of 2. So up 2 over 1, up 2 over 1. Here is my line. notice I hit the squiggle right there. And that dot I just drew, that big dot, is going to be an open dot. And since that's pointing that way, I'm gonna keep this part and erase all of this, right? All that didn't need it. Now, what shape is that?
V.
That's a V. Starting at the origin. Notice it hits right there. And that dot will be solid. And I will keep the left, pointing left, keep the left, and erase that little piece. And then it's up to you. You can leave that squiggly line in there, or you can take that out. There is your picture.
So if we do questions like this on the test, would there be like a pre-drawn graph, or are we just drawing our own?
No, there'll be a grid there for you.
Okay, nice.
Would it ever be one where both the arrows are going the same
No.
way?
No. Nope. Think about that, Kyle. Would it be a function?
No.
Nope. Can't have a function. All right, last section. Speaking of functions, we have 2x squared plus 1, and we have 3x minus 4. All right, number 1. What does that mean I'm going to do? Number 1, what am I supposed to do here? Plug 2 into F, right? And I'm gonna do that carefully. 2 into F would be 2 times 2 squared plus 1. Now what do I do first right there?
Squared.
Square. PEMDAS square. So 2 times 4, which is 8, plus 1. So this is 9. This guy right here is 9. Alright, there will be some goofball that does 2 times 2 and then squares it, and that will be wrong. PEMDAS, right? We gotta square first. Okay, and then I'm gonna put negative 3 into G. So negative 3 into G would be negative 13. Now, what do I do? I got this one to be 9, and I got this one to be negative 13. What am I doing with those numbers? Adding them. So the answer, the final answer to the problem is negative 4. All right, the next one says f of x minus g of x. What does that mean? I just subtract them, right? There's nothing to plug in this case. I'm just gonna take f, 2x squared plus 1, and subtract 3x minus 4. Now, where we could get into trouble here is if we forget to distribute that negative. You're subtracting the whole g. So 2x squared plus 1 minus 3x plus 4. And we'll just collect like terms. And then you're done. Do not solve that. Do not do the quadratic formula. You're done. Question said, what happens when we do f minus g? That's what happens.
If we solve it, do we get points off?
Absolutely. Okay, next one. What do I do with this one? It's a two-stepper. So I'll put 3 into G. Alright, so what do I get when I put 3 into G? 9 minus 4, I get 5, don't I? Okay, put a 3 right here. Braden? Got it? Then what do I do with the 5?
Put in for F.
Put it in here.
Uh-huh.
And this is another one, guys, be careful. We're gonna put 5 in, but what do we do first? Square it. Yeah, in fact, I got a couple of room you can have. I gotta see the garage yet. I don't have to spare. Remember who your favorite math teacher is, Mr. Young.
Go for it, you teach it here every year.
Alright, so F of 5. What did you get? You guys should have this done already. What did you get? 51, I hope?
Yeah.
51?
Yep.
Yeah, on that 51.
Okay. Alright, one more in this section. Oh shoot, I just got this in my phone. Alright, what does this mean? G of f of x. We're gonna plug in the whole thing. So we're gonna plug the F problem, this right here, we're gonna plug that into here. All right, everybody look up here, make sure you got that. This says take the whole problem, F of x, and plug it into G. So that will look like 3 times 2x squared plus 1 minus 4, which is 6x squared plus 3 minus 4, so 6x squared minus 1. And again, in this part, guys, we're not solving anything. That's the answer. All right, let's look at practice test 2. There's only 5 kinds of problems on this test, guys. Here we go. Practice test 2, which is on the back of practice test 1. And again, you're encouraged to do it on other paper, but it's up to you, whatever you want. And we're gonna do what we just did, so this will be good practice. Alright, now we've got 2 functions called m and n. Problem A. Can you do this? We just talked about it. Can you do this? What do?
Plug in N.
We take the n problem and put it here. So the n problem goes into m.
Yep.
So we have 4 times x squared plus 2 minus 3. So 8x squared, 4x squared plus 8 minus 3. I got 4x squared plus 5 as my final answer to that problem. What is B? What am I supposed to do in B? Plug in 2 to the m function. So what happens if I put 2 in here? Well, I get 8 minus 3.
Yeah.
So I get 5. Would everyone, can you figure out the m of 2 is 5? And then we're gonna find n of 3. What's n of 3? 11.
Yeah.
And what supposed to do this time with those numbers? Subtract. So our answer is -6. What does C mean? What do I do here?
Plug negative, or 1 into n.
Plug 1 into n. So what do I get when I plug 1 into n? What's 1 squared? 1 plus 2 is 3. And then what do I do? Take the 3 and put it into m, which would give me what? 3 into m.
1. I got 3.
Nice, you're wrong.
12
12.
minus
9.
Wow.
You put 3 right here. 4 times 3 minus 3. And then what does this mean? Don't make it hard. That little dot right there, that's a closed-in dot, that's not an open dot, that's a closed-in dot, and that just means multiply. So we're just gonna take m, and we're gonna multiply it times n, which means we're going to have to FOIL. So 4x cubed minus 3x squared plus 8x minus 6, I think. And again, that's it.
So you just got 12 minus 9.
Okay. All right, what about number 2? What's going on here? New problem, different kind of problem. Get y by itself. So we'll start by subtracting the 2x squared. And then we will square root. And then the test will have 2 answer blanks. So we'll put the square root of 6 minus 2x squared in one blank. And negative the square root of 6 minus 2x squared in the other blank.
Would it stay 2x squared or would it change to?
No, it doesn't change ever. We don't change anything. Anything you try to simplify will be wrong, so don't try to do it. You can't simplify this.
So we just put that into the calculator?
Actually, this is the answer to the question. It doesn't say sketch it. It says, what are the functions? There they are. Those are the 2 functions.
And we definitely want the spreadsheets on the test.
Huh? Your test looks just like this.
Okay, so no
You
schedule.
already asked me that question.
I know, just
So
clarifying,
just, no clarification. What does a test look like, people?
just like
This is what you need to know, right? Not to you to know it, but this is what you need to know. All right, number 3, find the domain. What should immediately pop into your head when it says anything about domain?
The 2 rules
The 2 rules. And what are the 2 rules?
Under the radical is greater than or equal to
You need the
0.
whole rule. You can't just say greater than or equal to 0. That is not the rule. What is the rule?
If it's
It is under the
If it's
radical.
under a radical, it's greater than or equal to 0. What's the other rule?
If it's a
If
denominator.
it's a denominator, then it can't equal 0. Okay? Those are the rules. So I got all 4 of my problems up here. So I'm gonna go through, I'm gonna do the first rule you said first. The order doesn't matter, but you said if it's under a radical, it has to be greater than or equal to 0. Okay, that's under a radical. So that has to be greater than or equal to,
1.
well, 0 zero, which means x is greater than or equal to one.
One.
No radical, no radical. Here's one. If it's under a radical, it has to be greater than or equal to 0. So x is greater than or equal to -2. Now, these are not my final answers. I'm going through and doing the work. I'm going to clean it up in a minute. Now, the other rule we said was, if it's a denominator, it cannot equal 0. If it's a denominator, it cannot equal 0. So x cannot be 1/3. Right? If it's a denominator, it cannot equal 0. So x cannot equal 3. Now, I've done my rules, so now I'm gonna write down my answers. What are my answers? Well, let's see. Can that easily be written as an interval? So I'm gonna have a bracket, 1, and an infinity. This does everything from 1 on. Okay? Easy. This one can be written as an interval, but instead of getting smaller, it actually gets bigger. So I'm okay with you reading it this way, but if you wanna write this, that is okay too. This would be the interval. I am okay with that, as I have been all along. I'm okay with that right there. But if you wanna write it as an interval, it looks like that. This is fine. What about this? I don't even have anything written down there. That's everything. Because the problem doesn't have a denominator and it doesn't have a radical. So therefore, I don't have anything written down, it's fine. This two-parter, we're just gonna write both pieces and that's gonna be our answer. Both parts, the blue and the pink in the box there, that's the answer to the question. All right, now we're back to our sketches. Let's see if we can get these done before the end of the period. What's the first one look like?
Absolute value.
It's a V.
Up 1.
It's gonna be up 1 and
Left
watch it. Left 2. Left 2. That goes left 2 and up 1. So I'm gonna have a V at -2, 1. Left 2 and up 1. What about B? This is another one that's kinda hard.
It's a half and half per
So
hour.
I'm gonna remember that it's a sign problem.
It's not true.
So I'm gonna go ahead and put in I'll dash it in. There's my regular sign, right? How high up and down does it go? 1. Where does it start? The origin. So now I'm gonna sketch the same thing, but I need to take it up 2. Now, keep in mind that the high point was at 1 and the low point was at -1. If everything goes up 2, then won't the high point be up here at 3? And the low point will be down here at 1. So the blue one is the actual answer. I just dashed in the original. Okay, what about C? What shape is C?
Parabola.
Parabola. It's a square. It's a parabola. Where is it? Not at the origin.
So it's right 1.
Right 1, down 1. Right, very good. There it is. What's x plus 2 quantity
A
cubed.
half and half parabola.
That's your squiggly half and half parabola. Only it's not gonna be half and half from the origin. It's gonna be half and half where?
Oh, negative.
Negative 2 to the left, yep. So then half and half parabola. Shifted left 2. What about E?
The out route.
It's the, normally it would start here and go up and out.
Down
Right?
two.
To the left one.
This one is left 1
Down
and
two.
down 2, so left 1 and down 2. I'll label my starting point and then up and out. And now our piecewise function, which is gonna be in 2 pieces. And my squiggly line is going to be at -1. So my first equation is a line with a y-intercept of -4 and a slope of 3, so up 3 over 1. I'm not, it's not a perfect drawing, I'm just trying to do my best. There it is. Now, what do you notice about that? Well, it hits our squiggly right there. That'll be an open circle. And I will keep just this part down here. So all that I just drew is not really there. Alright, and then what's the second part of that? What is this?
Absolute value. There you go. Up.
So it's a V, but it has been moved up
Just up,
1.
just up a step.
So here's my V, moved up 1. It hits right there. Solid dot,
Keeping the right side.
and keep the right side. So there is your picture. You've got this part of a V up here and this arrow thing down here. And then you can keep or not keep this little line. That's up to you. Alright, so I don't see on Monday, but we do have office hours on Monday. On Tuesday, we will do the last problem here and then the last practice test. And we'll be ready for our test. Again, please check your grade. I've got all these no-name papers back here. And at some point,